Hello everybody, this is episode 1 of Structural Engineering Explained. In this first video, it's going to be very basic and an introductory video. It's going to be on how to find an equations for moments in beams. Okay? So our first example will be very typical. You have a beam with length L, a load omega. If you look in any textbook or reference manual, whether that's the ASC steel manual, whatever, you Google it, the max moment here is WL squared over 8. How do we find this? That's the purpose of this video. So first what you want to do is you want to find the reactions here. Based on statics, W times L, you know you have WL right at the center at L over 2. Meaning by symmetry, this has to be WL over 2. This has to be WL over 2. Next step is we're going to cut this beam. We have an internal beam shear, internal moment. These are positive sign conventions. This one to balance this. All about equilibrium. Omega. This is at a length X, because you don't know where you cut it. And the reason why it's at a point X is because you want to make an equation that's going to work for a moment. For any point along here, you want to figure out the moment. So you don't want a hard code, in other words, if that makes sense. Now, we're going to do the same thing we did here. W and length X gives you some resultant of WX. This is applied X over 2. X over 2, correct? Now we're going to try to find your moments about this cut. So summation of moments about the cut, counterclockwise is positive. So that's negative WL over 2 times X, right? Plus WX times X over 2. Plus, don't forget your M, equals 0. I'm calling it W, it's omega, so I'm sorry if that happens. So you want to solve for M. This M is really M of X. It's M of a function of X. So you have WL over 2X minus WX squared over 2. Now you want to evaluate at L over 2 because we know that that is your M max that we talked about right here. That's right here at L over 2. Okay? How do we know that it's at L over 2? Just wait just a second. So now after we evaluate this, what is this? L squared. L over 2 squared, right? This becomes WL squared over 4 minus WL squared over 8. And finally, we get negative WL squared over 8. Look at that. These match. Now, moving on to the question of why or how do we know the max is at L over 2? Well, we know this being the shear diagram, right? L over 2 goes up to L over 2, then kind of linearly goes down, 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 down. The reaction pushes it back up, and that's your shear. Real quick, the reason why this is negative is this is positive bending, and you know, that's the convention. So when your shear is equal to 0, you know that your max, your moment is at a max. And that is a trick that will be very helpful sometimes for a more complex beam where it's not always obvious where your max moment is, and it might be a little difficult. You know, you can figure that out. Another thing that you can do is, we know that if we integrate shear, we will get moment. But what is integration really? Area under the curve, correct? So let's look at this piece, right? You have WL over 2, right? That's this length of this triangle. This length, L over 2, right? And so we want to find the area of this triangle. So area is 1/2 base times height. What do you get there? WL squared over 8. Look at that. 1, 2, 3. 3 ways to guarantee that this is correct. A fourth way would be, if you want to find this, we want to find the equation for V here, which the way we would do that rather is, you have WL over 2 positive minus WX, right? Minus V equals 0. So your V of X evaluated at X equals L over 2 is equaled, same thing, you can write it like this, equals WL over 2 minus WL over 2 equals V. So V of X equals 0. So V at L over 2 equals 0. There you go. Now we proved it again. Numerous different ways. Having all these different methods and different ways to look at things are going to just sharpen your toolbox and are going to give you the ability to rationalize beams that are a lot more complexly loaded. But this is the thought process that needs to happen in order to do that. So this is the very first episode. It's very short, very simple topics, but just to get my feet wet into this, and if I can have some suggestions on how to improve maybe lighting or cameras or anything like that. Maybe I don't speak English so well, or or my handwriting's garbage. Either way, let me know and I'll try to change that. Thank you so much, and thanks for watching.